Good morning, gang. It's Friday morning. Uh-oh, I was supposed to do this Thursday, but I had all kinds of craziness. But the good thing about a virtual course is I can stick it up there anytime. So no harm, no foul, as they say. We're going to talk today about chemistry. And you say, wait a minute, this is a biology class. But biology and chemistry, all of the biological processes depend on chemistry. And so what does that mean? That means we have to know a little bit about an atom. And so we're going to talk today about chemical bonding and atoms and all that good stuff. Well, it's not. We don't cover it like a chemistry class. We cover it like a biology class. So we'll talk about the atom in a very simplistic manner. And but before we get to that, I said I love this textbook, and I love this textbook because it's relevant. Now, in the textbook, it talks about HIV, which is a virus. But I think maybe it makes sense right now for us to, instead of talking about HIV, I should talk about COVID-19, which is also a virus. And so with viruses, they have a coat around them, and it contains proteins and it contains lipids. And one of the things, and again, these are chemicals. And on the inside, it contains something called RNA, another chemical, which you'll be learning about, not this lecture, but a later lecture. And so one of the things, if we think about what are the safety precautions that are associated with the COVID-19, one of them, everyone, we've talked about it at length, of course, is wearing masks. And that has to do with preventing the little particles from going from one person to another. The other thing, what is the other thing they say, in addition to 6 foot? Wash your hands. And believe it or not, you don't have to put alcohol, you don't have to put Purell on your hands to kill the virus. Soap will kill the virus. Why is that? It's because it tears apart the coat that surrounds the virus. And so if there is no coat, it won't stick to the cells that it needs to stick to infect somebody else. So believe it or not, washing your hands for 20 seconds is the most effective way of killing the virus. Okay, so this is all chemistry we're talking about. And we'll come back, and HIV has killed many people, and we're starting to get a handle on it. And we'll talk maybe a little bit more. We'll come back and talk some about it in a subsequent lecture. But for now, we're going to continue talking about these chemicals. And what are chemicals made of? They're made of atoms. And we have 118 different kinds of atoms that are identified, or I guess we can just say that exist. There are some, when you get to the larger atoms, there are some that are laboratory creations, and so even though they are truly atoms, they don't exist in nature. So we have 118 elements, and they're made up of different kinds of chemicals. When we talk about biology and the chemistry of life, we're going to be talking about certain kinds of atoms. There are certain atoms, hydrogen, carbon, oxygen. These are the atoms that make up most of biological molecules. So this is a biology class, so we're going to be focusing on them. So when you think of an atom, if you think of nuclear power, I'm sure you can envision that little thing with the nucleus in the middle and the electrons flying around the outside. And I said, we're going to talk about atoms in a very simplistic manner, so we're going to talk about the three main subatomic particles that make up an atom. There are people, there are physicists, there are chemists physical chemistry, people that are studying atoms and they're finding more little subatomic particles, but we don't care about them. We only care about the big ones that affect chemical reactivity. And so when we talk about these big ones, we have three different types of particles. And the first one we're going to talk about, the first two of these, are in the center of that atom, in what we call the nucleus. And in the center of the atom, we're going to have protons and oftentimes neutrons. Now, protons, I've written big and big here. Now, the reason I've written that is because there are two of the three subatomic particles have a lot of mass, and the third one we're going to talk about has a very tiny amount of mass. So when I say big, I mean they're going to contribute to the weight of the atom. When we get down here to electrons, we find that electrons are only 1/2000th the weight of these other two. So that's what we mean by big. So protons are big. They have a positive charge, and when we talked about, I said we're going to talk about different kinds of atoms that are important in biology: carbon, hydrogen, oxygen. What makes it carbon? What makes it hydrogen? What makes it oxygen is the number of protons. The number of protons determines the identity of the atom. If you have 1 proton, you are hydrogen. If you have 6 protons, you are carbon. If you have 8 protons, you are oxygen. This is the identity of the atom. Okay, and it's positively charged. In the center, in that nucleus, usually you have some neutrons. When we talk about hydrogen, you don't, sometimes you don't with hydrogen. But in most other atoms, probably all other atoms, you're going to have some neutrons, and usually they're somewhat equal, similar in number to the number of protons. And they are big, at similar size to a proton, and they have no charge. They're neutral. That doesn't mean positive, that doesn't mean negative, that means nothing. They don't have a charge, and we had said their number varies. Later here in a minute, and I'll go on and talk about this maybe, when we talk about atoms, individual atoms with different numbers of neutrons, if you have more of them, what would that make you? That would make you heavier, right? We had said the atomic weight, the weight of the atom, is primarily made up of the number of neutrons and the number of protons. We had said the electrons are so light, they contribute very little to the weight. So if we say, if an atom has extra neutrons, it would be heavy. And a heavy atom like that with extra neutrons, we're going to call a heavy isotope. Isotopes, this is a definition, isotopes are atoms with different numbers of neutrons. Write that down in your notes. Also, what else should you have written in your notes? Protons determine the identity of an atom, and they are big and they have positive charge. So all these main points, these are the things you're going to be questioned on. So heavy isotopes. Let's get back to where, don't get off track, Steve. Heavy isotopes. When you think of that, maybe you think of radioactivity. That's right. Heavy isotopes oftentimes are radioactive. So that's one reason we need to know about neutrons. The third kind of subatomic particle flying around the outside of the nucleus are electrons. And electrons are tiny. We said they are 1/2000th the mass of these other two particles. So when we talk about weight, it's almost insignificant. Chemists will pay attention to it, but you and I, we don't care about it. They're tiny. They have, that's a negative sign there. They have a negative charge. So what do they say about people? I'm running long here. So what do they say? Opposites attract, and in magnets and things also opposites attract, right? Positives and negatives attract. So the electrons that are flying around in orbits around the outside of the nucleus, the reason they don't go flying off is because they're attracted to the protons that are in the nucleus. They carry energy. That's why they're flying around. And sometimes they can have more energy, sometimes they can have less energy. All right, I'm going to stop right there. I've gone really long, 10 minutes.